Turn off the lights. Pitch black. It feels heavy, doesn't it? Darkness feels like a blanket. It feels thick. Now turn on a flashlight. The beam cuts through the room. It looks weightless, pure spirit, pure energy. We are taught from day one that light has no mass. We are told that darkness is just the absence of light. So obviously, light can't be heavier than darkness. Wrong. Not just a little wrong. Fundamentally, dangerously wrong. If I put a mirror box on a scale and pumped it full of light, the scale would go down. Wait. Actually, the scale would go up. Light has weight. If you hold a flashlight and turn it on, the flashlight gets lighter. That means the light carrying away the energy is carrying away mass. Darkness has zero mass. Light has mass. Therefore, light is infinitely heavier than darkness. But if light has no mass, and every textbook says it doesn't, how can it weigh something? To answer that, I have to break your understanding of what weight actually is. I found a loophole in logic, and once you see it, you can never unsee it. Let me show you. Let's start with a simple question. If I throw a baseball at your face, you flinch. You feel the impact. You feel the weight. If I shine a flashlight at your face, you don't flinch. You don't feel a push. You don't feel any weight. So your brain builds a logical model. Baseballs are heavy, light is weightless. And if you took physics in high school, you were validated. You were shown a chart of particles. Electron, mass. Proton, mass. Photon, zero mass. Here is where your high school teacher lied to you. Or at least they didn't tell you the whole truth. They are talking about rest mass, the mass of an object when it is sitting perfectly still. But here's the thing. Light never sits still. Light is always moving at, well, the speed of light. So using rest mass to measure light is like trying to measure the height of a cloud using a ruler. It's the wrong tool. We need to look at what's actually happening to the object creating the light. Do this right now. Imagine you are holding a super powerful flashlight, a massive industrial beam. You turn it on. Batteries are chemical energy. Inside that tube, chemical reactions are firing, creating electricity, heating a filament or exciting a gas, and shooting photons out the front. Energy is leaving the flashlight. We know energy is conserved. It has to come from somewhere. So, as the battery drains, the flashlight loses energy. But Einstein taught us that energy and mass are the same thing. They are interchangeable currency. Stop. Think about that. If the flashlight is losing energy, it is physically losing mass. If you put that flashlight on a sensitive enough scale, the numbers would tick down the longer you leave the beam on. The flashlight gets lighter. So where did the mass go? It didn't vanish. The universe doesn't allow deletion. The mass was converted into the light beam and shot away. The light is the missing weight. But wait, if light carries mass away, why can't we feel it? To understand that, we have to look at a regular AA battery. Take two AA batteries. Hold one in your left hand, one in your right. They look identical. Same brand, same size, same shape. But there is one difference. The battery in your left hand is 100% fully charged. The battery in your right hand is stone dead, drained. Now put them on a scale, not a kitchen scale. I'm talking about a perfect scale, a scale precise enough to measure individual atoms. Most people will tell you they weigh the same. They'll say, electricity isn't a fluid, it's just electrons moving around. You didn't add lead to the battery. Wrong. The full battery is physically heavier than the dead battery. Why? Because of the most famous equation in history, which almost nobody actually understands. E equals mc squared. You've seen it on t-shirts. You've seen it in cartoons. But stop treating it like a math problem. Treat it like a currency exchange rate, like swapping dollars for euros. Energy, E, equals mass, m, times the speed of light squared, c squared. This equation says that energy and mass are the same thing. They are the same guy wearing different hats. If you have energy, you have mass. If you have mass, you have locked up energy.
So when you charge a battery, you aren't just rearranging electrons.
You are pumping potential energy into the chemical bonds. You are packing mass into that metal tube. When you use the battery, the energy leaves, the mass leaves. So here is the question: why don't you feel it? Why doesn't your phone feel lighter when the battery dies? Because of the C2. The exchange rate is terrible. The speed of light is 300,000 kilometers per second. Square that and you get a number with 16 zeros. It takes a massive amount of energy to create a tiny speck of mass. For a AA battery, the difference between full and dead is less than a nanogram. It's lighter than a fingerprint. But, and this is critical, it is not zero. It is real. It is physical. Now, watch what this implies. The battery loses mass when it powers your flashlight. That mass turns into the light beam. The mass didn't vanish. The universe doesn't allow deletion. The mass was transferred to the photons. That means the light beam itself is carrying the mass of the battery away into the darkness. Light is a cargo ship carrying mass across the room. But if light is carrying mass, why doesn't it knock you over when it hits you? Why doesn't the sunbeam feel like a punch in the face? That sounds impossible until you see the trick. You turn on a flashlight. It's a laser beam. It hits a piece of paper. Does the paper move? No. This is why your brain says light is weightless. If I throw a ping pong ball at that paper, it moves. If I throw a photon at that paper, it stays still. So light must have zero momentum, right? Wrong. The paper does move. You just can't see it. The push is there. It's just incredibly, unfathomably small. But let's zoom in, way in, to the atomic level. Imagine a single electron floating in space. It's tiny, it's light, it's easy to push. Now fire a single photon at it, just one particle of light. When that photon hits the electron, it doesn't pass through like a ghost. It smacks it. The electron recoils, it gets kicked backward. This is called the Compton effect, and we've known about it since 1923. We have proven in labs thousands of times that light can punch matter. Wait, if light has no mass, how can it punch anything? In classical physics, the stuff Newton taught us, momentum is mass times velocity. If mass is zero, momentum is zero. Zero times anything, zero. So light shouldn't be able to push a single atom. It should be a ghost. But light cheats. Light doesn't play by Newton's rules. Light uses Einstein's rules. For a particle of light, momentum isn't about mass. It's about energy. Energy equals momentum times the speed of light. C. This means light carries momentum directly through its energy. It doesn't need mass to push. It pushes with pure energy. Think of it like a gust of wind. Air has very little mass, but a hurricane can knock down a house. Light is a hurricane of energy, and because energy and mass are two sides of the same coin, E equals mc squared, that energy acts like mass. It behaves like mass. It pushes like mass. So, if light pushes, can we trap it? Can we put light in a box and weigh it? Now, let's stop imagining batteries and ping pong balls. Let's build something impossible, something legendary, Einstein's light box. This is a thought experiment, but it is the key to breaking your intuition. Imagine a perfect box. Every wall is a flawless mirror, 100% reflective. Inside this box, it is pitch black, zero light. Now we seal the box. We put it on a scale. Let's say the empty box weighs exactly 1 kilogram. Exactly. Now we drill a microscopic hole and shoot a laser into the box. We fill the box with photons. Billions of them. Because the mirrors are perfect, the light bounces around forever. It never stops. It never escapes. It never gets absorbed. The box is now full of light. It is glowing with trapped energy. We seal the hole, and we put the box back on the scale. Does the scale still say 1 kilogram? Or does it say 1 kilogram plus the weight of the light? Here is the part nobody tells you. The scale moves. The box is heavier. The box has gained mass. Wait, how? The photons inside have zero mass. 0 plus 0 plus 0 plus 0 equals 0. So how can a box full of zeros weigh something? This is where your brain melts. It's not the photons themselves that have mass, it's the energy of the system. The energy trapped inside the box, E, has an equivalent mass, m. m equals E/c2. The box is harder to push. It resists acceleration more than the empty box. If you tried to slide it across the table, it would feel heavier. Why? Because the light inside has momentum. Every time you push the box, the light inside pushes back against the mirrors. The light inside acts like a trapped gas. It creates pressure, and pressure has mass. This means that mass isn't just stuff. Mass is trapped energy. Your body, it's mostly empty space with energy fields buzzing around. Most of your mass comes from the energy binding your atoms together. So, in a weird way, you are a box of trapped light. But is this just theory, or can we actually see light pushing things in the real world? Can we see light act like a physical wind? Yes, and we've used it to sail across the solar system. You might think I'm talking about abstract math, but this isn't theoretical physics. This is engineering. We have literally built machines that sail on light. Solar sails. Imagine a giant, impossibly thin mirror in space. It has no fuel, no engine, no rockets. It just sits there. And then it starts to accelerate. Slowly at first, then faster and faster. Why? Because sunlight is hitting it. The photons from the sun are bouncing off the sail, transferring their momentum. They are pushing it, just like wind pushes a sailboat on Earth. This is called radiation pressure, and it's strong enough to move a spacecraft across the solar system. The Japanese Space Agency launched a solar sail called Icaros in 2010. It worked. It flew to Venus, powered only by sunlight, no fuel, no exhaust, just light pressure. The light was the wind. But here's the kicker. You can see this effect every time a comet passes by. Look at a comet. It has a tail, right? A long, glowing tail pointing away from the sun. Why does the tail point away? Because the sun is blowing it back. The sun's light is literally pushing the dust and gas off the comet. The wind of light is strong enough to blow a comet's tail millions of miles into space. Wait, if light can push a spaceship, if light can blow a comet tail, does that mean light has weight? In a way, yes. It means light carries momentum. It means light exerts a force. But there is one more thing light does, something even weirder, something Einstein predicted but nobody believed until 1919. Something that proves light doesn't just push matter, light bends space itself. This is where gravity comes in. We all know mass creates gravity. The Earth pulls you down. But does light create gravity? Does a beam of light pull on things? The answer changes everything you think you know about the universe. And it leads us to the scariest object in existence. Gravity isn't just about mass. It's about energy. This is where your brain fights you. Most people think, big rock, lots of gravity. Small rock, little gravity. No rock, no gravity. Wrong. Einstein's field equations, G mu nu equals 8 pi t mu nu, say something very different. Gravity is curvature in space-time. And what causes curvature? Energy. Momentum, pressure, not just mass. Mass is just extremely concentrated energy. So a beam of light has energy, it has momentum, it has pressure. Therefore, a beam of light creates its own gravitational field. Stop. Read that again. A flashlight beam has gravity. If you shine a laser pointer, that beam is pulling the Earth towards it. Tiny? Yes. Measurable? Barely. Real? Absolutely. But wait, if light creates gravity, doesn't it pull on itself? Yes, light attracts light. Two parallel laser beams fired into space will slowly drift toward each other, not because of magnets, because of their own gravity. Now, imagine this on a cosmic scale. If you have enough light, if you concentrate enough photons in one place, you get a gravitational field so strong it warps space. It bends the path of other light passing by. This is called gravitational lensing. We see it all the time. Galaxies bend light around them like a lens. The light from distant stars gets distorted because it passes through a gravitational field. But what if you didn't need a galaxy? What if you could make a gravitational field out of pure light? No stars, no planets, just photons. Could you make a black hole out of nothing but light? Could you make a black hole so dense with energy that it collapses into itself? The answer is yes, and it has a name. It's called a kugelblitz, and it is the most terrifying object theoretical physics allows. The word is German, kugelblitz, ball lightning. But this isn't a storm cloud. This is cosmic horror. Imagine you could focus light, not just a magnifying glass. I mean really focus it. Imagine a laser so powerful it makes the sun look like a candle. You focus this laser onto a single point in space. You keep adding more energy, more photons. The energy density at that point skyrockets. The temperature goes to infinity. The pressure becomes unbearable. According to Einstein's equations, energy curves spacetime just like mass does. So if you concentrate enough energy in a small enough space, eventually the curvature becomes infinite. Spacetime snaps. The light collapses under its own gravity, and you get a black hole. A black hole made of pure light. No matter, no atoms, just trapped photons. A kugelblitz. This isn't sci-fi, it is mathematically possible. In theory, you could build a kugelblitz engine to power a starship or destroy a planet. This proves beyond any doubt that light has weight. If light can create a black hole, it must have mass, it must have gravity, it must be heavy. But if light can become a black hole, what about darkness? Can darkness collapse? Can darkness create gravity? Wrong. Darkness is the absence of light. It is the baseline. If you have zero energy, you have zero mass, zero gravity, zero curvature. So darkness is truly weightless. Light has weight, darkness has none. So mathematically speaking, light is infinitely heavier than darkness, because anything divided by zero is infinity. But wait, if light has weight, if light bends space, and if the universe is full of light, does that mean the universe itself is heavy? Does the light filling the cosmos actually weigh something? Yes. And this changes how we understand the very beginning of everything. Hold on. If light has gravity, if light can collapse into a black hole, if light is physically heavy, what about darkness? Is darkness just the absence of light? Or is it something else? Is it a thing? Or just a lack of a thing? Physicists call this the 0 point. Think of a scale. If I put a weight on one side, the scale tips. If I take the weight off, the scale goes back to 0. But does 0 exist? Can you have nothing? In quantum field theory, even empty space isn't truly empty. It is bubbling with virtual particles popping in and out of existence. This is called the vacuum energy. And even that has energy, even that has mass. But compared to a beam of light, it's effectively 0. Light is a concentrated form of energy. It is a disturbance in the electromagnetic field, like a wave on the ocean. The wave carries energy. The wave has height. The wave has power. But the flat water? It's just the medium. It's the baseline. Darkness is the flat water. Light is the wave. The wave has mass because it carries energy. The flat water has, well, it's just the water. So when we say light is heavier than darkness, we aren't just using poetry. we are making a precise physical statement. E0, mass 0, gravity 0. Darkness, E which is go 0, mass is go approximate 0, gravity is go approximate 0. This means light is infinitely heavier by comparison, because anything divided by 0 is infinity. The ratio of light's mass to darkness's mass is undefined, or infinite. It breaks the math. So, if light is heavy and darkness is lightless, does that mean the early universe was super heavy? Because right after the Big Bang there was no darkness, there was only light, blinding, scorching, infinite light. Let's rewind, way back, 13.8 billion years ago, the Big Bang. Right after the beginning, the universe was tiny, and it was packed with energy. So much energy that matter couldn't even form. No protons, no neutrons, just a soup of pure, blinding radiation, light. This era has a name, the radiation-dominated era. And during this time, gravity was ruled by light. Because there was so much light and it was so dense, the universe was incredibly heavy. The energy density was off the charts. And because energy equals mass, the mass of the universe was essentially just light. But as the universe expanded, the light stretched out. It cooled down. It lost energy. And because it lost energy, it lost mass. The universe got lighter. The gravity weakened. And eventually the energy dropped enough for matter to form. Protons, neutrons, atoms, the first stars. This is the craziest part. Most of the mass in the universe today came from that light. The light cooled down and turned into matter. EEM. Energy became mass. Light became darkness and matter. So you are made of cooled down light. Your atoms are just frozen energy from the Big Bang. You are walking, talking, thinking starlight. But there is one final piece to this puzzle, something even stranger than the Big Bang, something that connects light, mass, and information, something that suggests maybe mass isn't even real. Maybe it's just information. This is the end and the beginning. We started with a flashlight. We ended with the universe. But there is one final mind-bending thought. Information itself has weight. Physics tells us that erasing information requires energy. Erasing a bit of data, a 1 or a 0, generates heat. This is Landauer's principle. So, if information requires energy, and energy is mass, then information is heavy. A hard drive full of data is physically heavier than an empty one, infinitesimally, but heavier. Now, zoom out. The universe is full of information, every particle, every interaction, every beam of light. It's all data, and that data has energy, and that energy has mass. So, when we look at the universe, we aren't just seeing stars, we are seeing a giant hard drive. We are seeing a cosmic computer, and the mass of the universe is just the weight of the data it holds. And what carries that data? Light. Photons are the messengers. They carry the information from the stars to your eyes. They carry the heat from the sun to your skin. They carry the mass of the universe. So, when you look up at the night sky, don't think of it as empty space. Think of it as heavy with potential. Think of the darkness as the blank page, and the light as the ink. The ink has weight, the page has none, but together, they tell the story of the universe. It's not just light, it's information, it's mass, it's you. You are the light that slowed down. You are the energy that cooled. You are the universe observing itself, and that is why light is heavier than darkness, because darkness is just the stage, light is the actor, and the actor carries the weight of the show. If you enjoyed this deep dive, hit like and subscribe for more mind-bending physics.